Welcome to Ask and Learn.
Okay, so in this instance, we are given that there is a positive integer n, and it is the product of two primes, p and q. We also know the value of p minus 1 times q minus 1. Okay, well, since we know the value of p minus 1 times q minus 1, this is also equivalent to p times q minus p minus q plus 1, just from factoring. All right, well, this first part is a familiar expression, right? So we can rewrite this as being equal to n minus, and then I'm going to lump together the p and q here. So p plus q plus 1, right? Because this minus would distribute over both, so it's the same as minus p minus q. Okay, well, so we're headed somewhere. We know both n and the product of p minus 1 times q minus 1. So we can calculate p plus q as being equal to negative p minus 1 q minus 1 minus n minus 1. Okay, and so we get that from this expression here. Knowing that this expression is equal to p minus 1 times q minus 1, I subtracted the n, subtracted the 1, and then multiplied everything by negative 1. Okay, so then this is going to be the same as n plus 1 minus p minus 1 q minus 1. So that's just distributing that negative across the whole thing. So let's just say x is equal to p plus q. Then what we get is that x is equal to n plus 1 minus p minus 1 times q minus 1. And x is equal to, or I should say, x minus p is equal to q. Now, if n is equal to p times q, then what this implies is n being equal to pq is equal to x times p minus p squared. Okay, because we took p and we replaced q with this value here of x minus p to get this expression here. So this implies that p squared minus xp plus n must be equal to 0. That's what this whole expression means. And so we can determine the root of p using the quadratic formula. to solve this. And then once we know P, we can use the fact that Q is equal to N over P to solve for Q. And that is how we would find our P and Q respectively.